dear students, welcome to Maths Mentor, my YouTube channel. I am Reddy, your lecturer of mathematics and video tutor. Today we are going to discuss tangent and normal, which is a very important segment of chapter 6, that is application of derivative. You see, application of derivative. As per the CBSE, weightage of this chapter is around 11 to 12 marks. It is not exactly given. Of course, somewhere it is stated 10 marks even. You can expect this kind of arrangement. You can see a question of 6 marks and a question of 4 marks and a question of 1 or 2 you can expect. So today we are going to discuss tangent and normal. This is a basic video. So I told that from now onwards we are placing two kind of videos simultaneously, one by one. The first video contains all the particulars, all the concepts, discussion of and explanation of all the concepts and formulas and the basic question of that particular exercise. And the next video is directly we will go for the difficult kind of questions. In CBSE, both kind of questions may ask. Understand? We are categorizing two kind of videos because it is up to you which video you have to follow. Okay? We don't want to waste your time and your patience level we are considering. That is why we wish that you must put a proper focus. Of course, we would advise that you must go on both the videos one by one. Let's start. Tangent normal. For tangent normal, before tangent normal, we should know y is equal to fx. Y is equal to fx, as we know, this is x-axis, this is y-axis, so this is a curve. y is equal to fx is a curve. कैसा? अगर हमें कोई कर्व मिलता है y is equal to x square, as we know it is a parabola. While we put x different values of x, we will get a corresponding values of y. While we keeping in that way, I mean to say, जब हम x की values put up करेंगे तो we will get corresponding values of y. So ढेर सारे points आ जाएंगे. While we put one by one in that way, तो एक curve ऐसा मिलेगा. Of course, this is not a parabola. What I shown, it's merely an example. Well, so this is a curve. Chapter 6 entirely based on a function, on a curve and its understanding. A tangent and normal give you a very nice explanation of the curves and its relevant concepts. Now, what is slope? First of all, while we come to the slope, we must have read in the 11th class, slope का मतलब होता है कोई भी लाइन x एक्सिस के साथ जो एंगल बनाती है उसको हम लोगों ने स्लोप कहना सीखा. tan theta is equals to m. This is our slope, also known as gradient. Okay. There we know that if we two points are known x1 y1, okay, x1 y1 and x2 y2, then we can come to know the slope of the line y2 minus y1 upon x2 minus x1. For parallel lines, m1 and m2 are equal. For perpendicular lines, you know, for perpendicular lines, m1 into m2 equals to minus 1. These are the things which we have read there. Now we are going to equate this slope with our derivative. Understand? डेरिवेटिव मतलब हमने किसी लाइन किसी कर्व को हमने डिफरेंशिएट किया. व्हाट वी गेट देयर, दिस थीटा आल्सो बी गिवन बाय डिफरेंशिएशन ऑफ द कर्व. dy बाय dx जो हम करते हैं, जो f डैश x आता है, ये स्लोप है, स्लोप ऑफ टेंजेंट. while we put any value dy by dx x1 y1, सपोज हमने इस पॉइंट को पुट कर दिया x1 y1 डिफरेंशिएशन के बाद, तो हमें बोलते हैं स्लोप ऑफ टेंजेंट, स्लोप ऑफ टेंजेंट एट x1 y1. उस पर्टिकुलर पॉइंट पे हमें स्लोप निकल आता है. तो स्लोप dy by dx, tan theta, all are synonymous from now onwards. तो ये सारे एक जैसे होते हैं. m कहो tan theta कहो, call it as a tan theta or dy by dx. So slope of tangent it is. What about the slope of normal? Slope of normal is equals to minus 1 upon में dy by dx. This is a tangent as you know, and this one is a normal. So this one which touches at a point, it is a tangent, and this one is a normal. In that way we came to know two aspects of this chapter. Okay, let's continue. So consider some more points. If the thing is like this, if the curve is given and the tangent is this, y is equals to fx, and this point is x1 comma y1. We are interested to talk about normal and tangent. Okay, so equation of tangent, our next step is that equation of tangent. As we have studied in the 11th class, okay, equation of a line carries which passes through a given point. x1 y1 is known to you, suppose, and the slope is given to you. Then equation is y minus y1 and x minus x1 is equals to m. This was the concept there which we used in the straight line. Now here what is that? Slope is replaced by the dy by dx, है ना? हम उसे replace कर देंगे. Equation of tangent will be like this, dy by dx at x1 y1. Of course, equation of tangent you will get that. Now equation of normal, what about that? Equation of normal is equals to similarly y minus y1 and x minus x1, and minus ka 1 upon में dy by dx. We will use that. Okay, we can make it reciprocal also. So these are the two things which we have to take care. After this we will find some cases. What is that? Case that if tangent parallel to given line, suppose any given line, we must do dy by dx of that curve equal to slope of the given line. Tangent parallel to given line. Okay, if tangent perpendicular to given line, then dy by dx into slope of that line equals to minus 1. We have to do in that way. Now third part, if a tangent parallel to the x-axis, as usual, suppose any tangent is like this which is parallel to x-axis, we have to keep dy by dx must be equals to 0. Slope of that tangent will be 0. Similarly, for perpendicular to x-axis, we must do 1 upon dy by dx equals to 0. In this way, we got some of the basic concept of this exercise. We will go for the questions. Here are the two basic questions I took here from 6.3. We will do one by one. First we have to get the slope of normal. It's a parametric equation, you see. Slope of normal we have to find at theta is equals to pi by 4. I will solve this question. Slope of normal, either slope of normal, slope of tangent. You have to get first the dy by dx of that curve. Because it is in parametric form, we have to differentiate individually. A cos cube theta और y is equals to a sin cube theta. बारी बारी से दोनों को डिफ्रेंशिएट कर दीजिए. डिफ्रेंशिएट विथ रिस्पेक्ट टू थीटा. dx अपॉन में d theta a derivative of theta cos का cube theta. So you will hear a little bit of chain rule, 3 cos square theta आएगा. फिर cos theta का हम करेंगे, माइनस का sin theta will appear. Okay, keep this one. dy by d theta पे आइए. dy by d theta पे आएंगे d पावर की 3 sin square theta and sin theta की डेरिवेटिव cos theta you will have. Therefore dy by dx, if you wish to find you have to write in this way, dy by d theta and then dx by d theta. By that हमें क्या मिलेगा? We have to put 1 by 1 3a sin square theta into में cos theta minus 3a cos का square theta into में sin theta. कट करके ये क्या मिलेगा? sin theta by cos theta minus का. You will appear at tan theta. This is there. dy by dx you got. Then our task is over. Therefore slope of normal is equals to minus का 1 upon में dy by dx. At that point of course minus का tan theta हम put करेंगे, theta की value pi by 4 you know, that is equals to 1 minus 1. The slope of tangent आपको आ गया, slope of normal. Draw a figure always while you do the question of tangent and normal. Okay, curve equation means a figure which makes the evaluator more understand, even you also. तो हमने ये क्वेश्चन कर दिया. आइए नेक्स्ट क्वेश्चन की बात करें इसी में. क्वेश्चन नंबर 7, these are basic questions. Find the point on the curve. इस कर्व पे हमें वो पॉइंट फाइंड करनी है जो एक्स एक्सिस के पैरेलल है. सॉल्यूशन. नाउ एज आई यूज्ड टू डू, दिस इज देयर सपोज, है ना, वी कैन अंडरस्टैंड अ कर्व लाइक दिस. वी हैव टू फाइंड अ टेंजेंट those points. Of course these are the points which are question mark. This you have to get here. Call this one as a P and this one as a Q, which are where the tangent will parallel to x axis. Okay, this one is x and y. Let P, Q are the required points. We don't know whether the both 2 points or 3 points will come. We will call, better to call this one as a only one point. P, x, comma y are is the points, is the required point. We call this one as like this. If there are 3 points, then it will be there. It will come out automatically. So curve is given to you x cube minus 3x square minus 9x plus 7. अब हम differentiate करेंगे dy by dx. Here we have 3x square minus का 6x of course and minus 9. This we have. We will say that for tangent parallel to x-axis, for tangent parallel to x-axis, what we have, dy by dx must be equals to 0. This is the concept we are going to use here. तो हमने इसको 0 किया, 3 को कॉमन ले सकते हैं आप, माइनस का 3. सो स्प्लिट द मिडिल टर्म्स, एक्स स्क्वेयर माइनस का 3x प्लस x माइनस 3, 0 x will take as a common plus 1 x minus 3. In that way what we have, x minus 3 and x plus 1 equals to 0 आ गया हमें. अब हम बारी बारी से वैल्यू निकाल लेंगे. minus 1. I told that I was not aware whether the 2 points will come out or not, but coincidentally we got 2 points. So at x is equals to 3, you have to do one thing. You must put the value because they asked the points, है ना. Where is the curve? Yeah, x cube minus 3x square minus 9x plus 7. At x is equal to 3, 3 की cube minus 3 into 3 का square minus of this. It will cancel out, minus 27 plus 7 minus 20. So therefore P x comma y is a point like that, 3 comma minus 20. Of course, okay. Well, we got one point. Similarly you can get other point at x is equals to minus 1. It's your duty to get that, है ना. इस तरह से हमें 2 points. These are the basic questions where you have to apply the basic concept. Here we have a question number 10 of 6.3. We are continuing the exercise. What is that? Find equation of all lines having slope minus 1 and that are tangent to the given curve. What does it mean? Let's have a figure first. वी हैव ए कर्व लाइक दिस, है ना, हमें वो सारे टेंजेंट्स फाइंड आउट करने हैं। इस कर्व पे बहुत सारे टेंजेंट्स, सो मेनी टेंजेंट्स आर पॉसिबल, यू नो, हाँ, so many tangents are possible. We have to find those tangents which have slope -1. Understand? Which have slope -1. Suppose that the required tangent line is like this, suppose, है ना, P H comma K. I used to say H comma K or x1 y1, you can say. Suppose we are calling that the required tangent. Let the required tangent passes through, okay, passes through h comma k. हमने कह दिया h comma k से पास होती है. This you have to get, okay, this you have to find out equation of tangent. Let's go on. What we have to do first, we have to differentiate the curve. Differentiate करेंगे, dy by dx is equals to derivative of x minus 1 का power -1, it will be there like that, okay. So -1 will appear as a coefficient, then -2, differentiation of x minus 1, again this gives you 1 only, so ultimately 1 upon x minus 1 ka whole square, it is the dy by dx, okay, slope of this. Therefore it is the general slope. जब आप differentiate करते हो तो इस पूरे कर्व पे हर जगह पे we are getting the slope of tangent for which is eligible for each and every point on the curve right now. But while we put a particular point, then it will be the tangent of that particular point, okay. So at p h comma k, you can say h comma k जैसे पुट करोगे आप तो dy by dx is equals to -1 upon h minus 1. In place of x you have to put here x minus 1, okay. Now dy by dx, according to question, we know that the slope of tangent dy by dx is equals to m, that is हम equate कर देंगे दोनों को, the slope must be equals to -1, so minus minus gets cancelled, 1 is equals to h minus 1 का whole square. We can go for that, h square minus का 2h फॉर्मूला खोला हमने, 1 gets cancelled, h square minus 2h will be 0, h की वैल्यू 0 और 2 आ गई. So we were trying for the only 1 point, but instead we are getting 2 points, okay. No way, no problem. At h comma 0, what will be the k, means y is equals to 1 upon x minus 1. तो y की वैल्यू k पुट करेंगे, x की वैल्यू 0 पुट करते हो आप, you will get -1. तो call this one as a phk, p की वैल्यू 0 comma -1, one coordinate you got here, and the other at h is equals to 2, okay, k becomes 1 upon 2, we are getting 1. So call this one as h comma k, 2 comma 1. Now we are having 2 points. Sir ऐसा कैसे होगा? Because we don't know the curve how it goes on, we drawing the simply a rough curve. So it may have 2 curves like this, one you can call as a P and the other one you can call as a Q. 2 पॉइंट्स पे ये वाली बात हो रही है. इसका मतलब क्या, कौन सी बात, x की स्लोप -1 की होने की बात है, ओके. ना व्हाट, अब सब काम हो गया हमारा, हमने केवल टेंजेंट निकालना है, ठीक है ना. टेंजेंट निकालना हमें आता है एट पॉइंट P, इक्वेशन ऑफ tangent, what it will be, y minus y1 x minus x1 is equals to dy by dx at p. In this way we have to write. तो y minus y1 की वैल्यू at p पॉइंट पे हम अगर हैं तो y minus y1 की वैल्यू will be -1, then it will be plus, then x minus 0, and the slope of this line is equals to -1. Already we are having y plus 1 is equals to -x, then x plus y plus 1 is equals to 0 is one of the tangent at q. Simply 2 comma 1 you can do, you will get the other equation. Okay, so in this way we concluded the basic part of the tangent and normal exercise. Okay, these 3 questions, I will put 3 or 4 more questions of difficult kind a little bit in the next video. So have these concepts first and revise a little bit and do a little practice, the things will be automatically easy. You must know one thing: timely practice and timely study helps you a lot in your examination, so you must keep it on. And one more thing at last, before completing the video, I would like to say, if this video you got that it is a purposeful for you and you're having a enjoyment while you're learning, then you must subscribe this channel. ठीक है, आप सब्सक्राइब कीजिए इसे और आगे की वीडियोस के लिए नोटिफिकेशन के लिए बेल आइकन भी दबाना. ठीक है, मिलते हैं अगले वीडियो में. ऑल द बेस्ट.